Function pattern recognition. We have been looking at different types of functions in the context of stories and graphs and tables. Today we're going to name those functions linear, quadratic, exponential, and absolute value based on their graph. Find this page in your binder in the Unit 1 packet. These first few pages are what I call anchor pages or anchor notes, and we will refer to these pages often, so we're anchoring those. Usually I'll want you to put a flag on those pages so they're easy to find as we add more to our binder. And we're going to continue to add details throughout the year as we learn more about the 4 functions. So hopefully this looks familiar to you. A hot air balloon starts at an altitude of 500 meters. It is descending, which means going down, by 10 meters per minute. This was scenario 11 from our card sort. This is representative of a linear function, and we're going to keep coming back to this slide as we add more details about linear functions. A word that you might see associated with this is line. So when we see linear, I like to keep in mind that the word line is part of the word linear, and this is a constant change, meaning it is always increasing or always decreasing by the same amount. And this particular graph was a graph that was falling, so something like this, but other linear functions that we had in our card sort were increasing, so they could go in either direction. And let's take a look at this table over here. So one thing we do when we're looking at a table, and we'll go into more detail in the next lessons, is to look at what is the change happening for the change in X and the change in Y. And what I mean by that is when I go from 0 to 1, that is an increase of 1. From 1 to 2 is increasing by 1. From 2 to 3 is increasing by 1. From 3 to 4 is increasing by 1. And from 4 to 5 is increasing by 1. When I look at the change in Y from 500 to 490, I'm decreasing by 10, decreasing by 10, decreasing by 10. So if I needed to fill in the rest of this table, I would know that that pattern is going to continue decreasing by 10. So 470 minus 10 is 460, and 460 minus 10 is 450. So the next example we have here of the function types is quadratic. An example of a quadratic function is the catapult problem. So standing on a high school roof 24 feet up, catapulting marshmallows at the 8th graders going into a nearby middle school, you hit a kid on the head who's 5 feet tall. This was scenario 13 from the card sort. Some words that I think of when I'm thinking of quadratic would be anything that has to do with a projectile or that is affected by gravity. And the graph is called a parabola, which is just a U-shaped curve. All U-shaped curves have a change in direction, and that change in direction is called a vertex. This is also called a turning point. And so those graphs might look something like this or something like this. So it could be a U shape opening up or a U shape opening down. Let's take a look at the table. And if you look here, this is the table that corresponds to the catapult problem. You can see here that the X values, the time, is increasing. So as you go down the list, the time is getting bigger in seconds. With the feet for the Y value, 24, 34, 40, 42, those are all increasing. Then from 42 to 40 is decreasing, and from 40 to 34 is decreasing. When we have that change in direction, so we are increasing to 42 and then decreasing after 42, that lets us know that this right here is our turning point. Or we might call that a vertex. Another type of function that we're learning about are exponential functions. And an example from our card sort was the population of a microbacteria starts at 100 and triples every day. That was scenario number 10. And some words that you will see associated with exponential are population and really anything that is naturally occurring. The graphs look like what we call a lazy L, so it's just like a sloped L like this, or it would be the reflection of that. So it might look something like this. Notice that there is no turning point in this curve. So it's always increasing or always decreasing. And some other key words, like in this problem, you see that we have triples. In other problems from our card sort, you had doubles, it could half. But it's changing by a multiplier. Finally, if you look at the table, you will see that the x values are increasing. So the days, as the days get bigger or go forward in time, the y values or the bacteria is tripling. 100 times 3 is 300, 300 times 3 is 900, 900 times 3 is 2700. We will continue to talk about this more later in our studies. The last of our 4 functions is absolute value, and an example from our card sort was the irrigation problem. A farmer's irrigation canal from a reservoir is opened, which lowers the water from the reservoir 15 feet each day for 12 days. After this, the canal is closed. Then the water is directed from a river to the same reservoir to raise the water level back to its original level of 500 feet. Also at 15 feet per day. And this was scenario number 14. So again, with words that we're looking at here, you would notice that there is a direction change. So something going up, then down, or down, then up. Also, you notice in the graph that it would be a V shape. You will also notice that there is a rate given. So 15 feet per day. And then going back up, it's also 15 feet per day. The graphs, like we said, are always V-shaped, so it could be a V opening down or a V opening up. You can see in this example that the X values, which is the days, are increasing over time. They're getting bigger. The Y values, which is the water level, from 365 to 350 to 335 to 320 are getting smaller, and then it starts going back up again. So this again shows us a turning point. And this is the point at which it changes direction. We're going to call that a vertex. Just a quick summary here. You don't have to write this down. You already have it in your table, but a linear function is always going to be a straight line. So it could be going increasing or decreasing. Absolute value is always a V shape. That V shape can be going up or it can be going down. Exponential is what I often call a lazy L. So you might see it sloping down like this, or it can be a backwards L sloping up like that. And quadratic functions are always U-shaped curves. So it's increasing and then decreasing, or decreasing and then increasing. So it can open up or it can open down.